Welcome. Today we will be discussing section 3.2. Topics include triangular geometry, law of cosine with side problems, side angle side problems, as well as some area of a triangle problems. So to begin, we want to build up to the notion of what side angle side, and later on in future videos, angle side angle, and other combinations of these letters. So triangle geometry is what we'll use to denote what we mean by these kinds of problems. So when we build a triangle, we will have an angle C with side C, angle A with side A, and angle B with side B. We can orient this triangle however which way. The labeling is arbitrary. Another use of labels that you'll often see is instead of labeling these as angle A, angle B, we'll instead take alpha to be associated with side A, beta be associated with side B, and gamma to be associated with angle or with side C. And when we say side, angle, side, pick a point of the triangle and just kind of work around the triangle. Whether you do it clockwise, counterclockwise, it doesn't really matter. You just have to be consistent with what you call it. So in a side, it doesn't really matter because I'm saying that I'm giving you the information of all three sides and they connect up. Or if they connect up, they'll solve one triangle. If I give you side, angle, side, that would be where, so I'm going to start with this point here. I give you B, I give you gamma, I give you A. I went in a clockwise fashion there, but if I started from this vertex and worked my way across, I could go with side, angle, side and get the same. Or I could have started from this vertex and went across. The reason why I suggest starting at a vertex is because if we have like an angle side angle question, if I start on this vertex, I have my angle, my side, and my angle. And again, whatever makes most sense to you, just be consistent with your orientation of the information. So if I say side, you can think of it that I give you the information here for each of the different sides. If I say side, angle, side, you could imagine that I give you this, and this. If I say angle, side, angle, that would be the orientation of an angle, a side, and an angle, and angle, side. We could, again, start with an angle, another angle, and then a side. I worked in counterclockwise in these situations, but again, whatever suits your preference. Just be consistent with labeling. The stars mean that like I'm giving you that information. Yeah, so for the law of cosine, we have the following. We have a squared equals b squared plus c squared minus 2bc cosine of alpha. We also have b squared equals a squared plus c squared minus 2 ac times cosine of beta, and c squared equals a squared plus b squared minus 2ab times cosine of gamma. So you could look into this and for kind of memory's sake, a squared equals b squared plus c squared, and we have that sort of identification from Pythagorean's theorem, and this will hold for a right triangle, provide correct orientation. However, this works with any triangle, and for that we include minus 2 BC is the lengths that are on the right side of the equation. Cosine of alpha, alpha is the angle of the side on the left side of the equation. And that is consistent throughout here. So I have AC, beta for the B, AB, gamma for the C. And we'll use this for side, and side, angle side problems. This is where it's used. So let's see an example of this. So if I say, let's first talk about SSS. So side, case. Let's first come up with a couple of rules on how we can best answer such a question. So first, we have side 1 plus side 2 must be greater than side 3. Now, this might seem a little arbitrary, but we're going to take the smaller, so these are so you can think of this as smallest, and then second smallest, and then this is the greatest. This is the greatest side, second, and then the other sides. So this would kind of intuitively make sense, because if I have a triangle that's 9 inches long and I have 2 side lengths that are let's say 4 inches and 4 inches, 4 inches, 4 inches, I'm an inch short. I can't make a triangle. There's no possible way to do that. So I'd have to get it where these sides must be greater than, because if they're equal to, I still wouldn't have a triangle. Say if I went 4 inches and then 5 inches, there's no angles here. I just created an overlapping line segment. Once I have like 4 inches and then 6 inches, that's where I can now finally get a triangle to be created. So our first check is to ensure that this holds. If not, no solution. If yes, then use law of cosine. I'm just going to abbreviate LOC, law of cosine. So, first example. we have A equaling 7, B equaling 5, and C equaling 3. We want to solve the triangle. So I'll first go, all right, what is my greatest? That's 7. So we have 7 squared. Is this greater than 5 squared plus 3 squared? Well, 7 squared is 49. And then 5 squared is 25. 3 squared is 9. And so we get oh, where I'm not supposed to square this. What am I doing? Sorry. Got Pythagoras theorem on the brain. We just want to test out this. 3 plus 5, that is 8, which is certainly bigger than 7. So that's a good check mark. And so now we want to use law of cosine. So we want to solve this. So we can use any such one of these. We just have to be consistent with labeling. So we have A, B, C. So let's start with the first law of cosine. So we have A squared, 49, is equal to B squared, 25, plus C squared, which is 3 times 3, it's 9, minus 2 times 7, sorry, 5 times 3 cosine of alpha. So we then have this is 49 equals 36 minus, and we have 10 times 3, 30 cosine of alpha. Subtract the 36 across, divide by negative 30. And when we subtract this across, we're left with 15. So divide by negative 30, and we're left with negative 1/2 is equal to cosine of alpha, which then, when we take cosine inverse, we have alpha is equal to cosine inverse of negative 1/2. So this is negative, so we know we're going to be greater than 90 degrees. And when we evaluate this, we're going to have 2 pi over 3. That's our value. Again, it's just 2 pi over 3 because we want the geometric angle, so it's a positive angle the first time that we land at such a value on the unit circle. Okay. So let me box that in. So we found alpha. Now we need beta and gamma. So for beta, we'll do the exact same thing. B squared, or we'll use the second line. So we're going to have B squared, so that's 25 is equal to A squared plus C squared minus 2 times A and C times cosine of beta. We're going to solve for beta. So we're going to add these together, subtract them across. So we got 58, subtracting 58 to the other side, and we get negative 33 is equal to, and here we have negative 6 times 7, so that's negative 42 cosine of beta. divide by negative 42, and we get 11/14, which is equal to cosine of beta. And we can take cosine inverse of 11/14, which is approximately 0.667 radians, which is equal to beta. So there we have beta. And we can get delta, or sorry, gamma, in one of two ways. We could put it through this process again, and on a test or a quiz, I would highly use this way to check your work, because it should also work in this last equation. But we can also take pi and subtract pi from take pi and minus 2 pi over 3 minus 0.667. And because we know that the triangle adds up to 180, and that will get us our solution as well. So this leaves us with 1/3 pi minus 0.667, gets us approximately 3 or 0.3 3. So either way we do it, we'll get approximately the same answer. Note that this isn't 2/3, 1/3. We took a trig identity and or cosine inverse, just so happen to work out to those numbers. So with example 2. So let's assume we have A equaling 5, B equaling 10, and C equaling 17. We want to solve the triangle. So we first do our check and do 17. Is this less than 5 plus 10? 5 plus 10 is 15. No, it is not. So no solution. Okay. So the important thing is to always do that check, and you'll get your answer. So now let's go to example 3. And this is a side angle side case. So we want to do the exact same process, but in the side angle side case, we're never not going to have a solution. We can always find a third side length such that it's true. So this is the best case. It's sort of similar to when we were doing the parallelogram in previous video, where if we had V and W, we could always construct a triangle, or we could always construct a parallelogram as long as these were non-zero and not the same direction. Same case here with a side angle side, we're always going to be able to construct a a triangle. So let A, so there's no check required. Just go for it. So we have A equaling 10, B equaling 5, and gamma equaling 35 degrees. So we know that this triangle is going to look something like this. Not drawn to scale. So let me get this. Maybe 10, 5, 35 degrees. Okay. So we have to find what this angle is, and this angle would be beta. We want to find what this angle is, and this angle would be alpha, and we want to find what C is. Those are our unknowns. So we can just plug in any which one of these equations, but for the law of cosine that I covered up, but let's choose C squared is equal to A squared plus B squared minus 2AB cosine of gamma, which we know is 35 degrees. Let's fill in the rest of the information. We know that our A and B's, we can fill this in. So we have 10 squared plus 5 squared minus 2 times 10 squared times 5, or 2 times 10 times 5. So we get C squared is equal to 100 plus 25 minus, this is 10 times 10, so 100 cosine of 35 degrees. We plug this into our calculator and we find that C squared is equal to about 43.08. So C is about equal to 6.56 units. Again, we're talking about distances in a triangle, so we're going to include units. I will say that I would prefer for you to round until the very end. So to clean this up, I think a better step to plug into your calculator would be C is equal to square root of 125 minus 100 cosine of 35 degrees. Because now we have an exact answer and we're estimating from here and not compounding an error. Okay, so that got us C. So we know what C is, but we need to find the other two angles. Well, we can just kind of pick to solve one. So let's pick for alpha. So A squared is equal to B squared plus C squared minus 2BC cosine of alpha. So substituting that in, we have 100 is equal to, and we have 25. C squared, we had what C squared was. Let me write that down again here as 43.08. So I'm just going to shorthand and put 43.08 minus 2B, which is 25, C 43.08 times cosine of alpha. And we can solve for this by solving for alpha, subtracting these values, dividing by this value or this coefficient, and then taking cosine inverse of it. And we'll end up finding that alpha is equal to the cosine inverse of about 0.4866, which is equal to 60.88 degrees. That's approximately equal to 60.088 degrees. And that is my alpha. And for my beta, I can again go through the whole process. I would use that as a check your work, but we can just approximate it by going 180 degrees minus 60.88 degrees. And then minus 35 degrees, which is equal to 84.12 degrees. That's approximately our beta. So there are our three missing values. Now notice in the previous question, we didn't include units because they're in radians, so we omitted the radians as units. Here we have to include units for side length, and we include degrees to denote that we are in degrees units, not radians. Okay, so for the last topic of this lecture, we'll talk about the area formulas, which is pretty simple, and you'll find these generally in conjunction with other questions. So once you are able to find all the different values of a triangle, so side A, B, C, alpha, beta, gamma, we'll then ask you for the area of a triangle. So we know from past like 1/2 base times height, but we're not given heights, we're given side lengths. So the area of the triangle T is equal to 1/2 AB sine of alpha. Now, if you look and you can kind of think about this, we have A times B. So if we look here, we have A times B. Sine of alpha is here, which is opposite over hypotenuse when you think about it in that context. Well, what is the opposite? What is the hypotenuse? Well, in context, the hypotenuse of this angle would be B. And the opposite, if we make it B and drop down in altitude, we would then have the height of the triangle, making a right angle with side C, that's what an altitude is. And that would just cancel out, giving us the height. So we have height times A, which then we take 1/2, and we get our triangle. So that's essentially all that is. Well, since we generalize this triangle, we could do this with any combination. So let's do BC, and we're going to take the sine of which angle. The angle is of gamma. And we can have Oh, whoops, I'm messed up. This is gamma, this is alpha. Same sort of trick, just a little bit of different nomenclature. Different reference angle. It does the same exact thing. You just swap the labeling of the sides. And to finish up, we have 1/2 AC sine of beta. So I apologize for messing that up, but in reality, all that we did, all that the error that I had was just targeting a different reference, which as long as you are consistent with your referencing, you'll be fine. Yeah, I confused the nomenclature, but that's okay. So anyways, this would get us our solution to any such triangle. So for final example, so example 4, if we have A equaling 10, B equaling 8, and C, and so angle C is equal to pi over 4, then remember that this angle C we could rename as gamma. And now we use our area of the triangle. That's what we want to find, is equal to 1/2 times 10 times 8 times sine of pi over 4. This is square root 2 over 2. So we get this is 5 times 8, so we get 40 square root 2 over 2, which is equal to 20 square root 2. And we'll call that units squared. That is the area of the triangle, is 20 radical 2 units squared. Now, if we left this as 40 divided by radical 2, I'm not going to flag you for that, but this is like more proper notation. Okay, so with that, your check on learning today will be to write down the law of cosines, write down each and every one of these, as well as write down these 2 questions that you'd be using them. So law of cosine is used in side, 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 and side angle side questions. So write that down as well as the formulas for law of cosine. Thank you and have a great day.